In 2009, Usain Bolt ran 100 meters in 9.58 seconds, setting a new world record. A model for his speed is v equal to 1 minus 0.4 t squared plus 4.4 t, where t is the time in seconds. When he reached his maximum speed, he continued to run at this speed for the rest of the race. Find the distance in which Usain Bolt ran at this constant speed. This, here we have the formula v equals to 1 minus 0.4 t squared plus 4.4 t. We have to change this formula into the standard quadratic equation, which is ax squared plus bx plus c. So now we have to switch the places of the variables, and we have v equals to minus 0.4 t squared plus 4.4 t plus 1. As you can see, we only switched the places of the variables, nothing more. Now we can determine the values of a, b, and c. In our case, a equals to negative 0.4, b equals to 4.4, and c equals to 1. Our next step is to find the shape of the speed. From the quadratic equations, we know that the shape of the parabola is determined by the value of a, meaning when a is greater than 0, the parabola looks like this. When a is less than 0, the parabola looks like this. Now, in our case, a is negative 0.4. So we know that the shape of our parabola is like this. We start building our graph. So here we have the y-axis and here we have the x-axis. But in this case, in the x-axis we'll put the time t, and in the y-axis we'll put the value v. Here we have to pay attention. Usain Bolt ran at parabolic speed until he reached the vertex, the maximum speed. After that, he continued with a constant speed until the end of the race. So, if the vertex is a point, let's say K, Usain Bolt would run at parabolic speed until he reached the vertex K, sort of like this. And then after he reached the vertex, he would run at constant speed until the end of the race. So the graph for the Usain Bolt would look like this. Now we have to find the coordinates for the vertex K. The coordinates usually are x and y, but in this case the coordinates are the maximum speed, so Vmax, and the time in which Vmax is reached, so TV max. So now we have to find TV max and V max. From math, we know that the y coordinates of the vertex, in our case t, v max, are equal to minus b over 2a. We have a, we have b. So we do the math. Minus 4.4 over 2 times negative 0.4, which is equal to 4.4 over negative 0.8, which is equal to 5.5 seconds. So now we know that TV max is 5.5 seconds. We write down here 5.5 seconds. Now we have to find Vmax. We have the formula for V, and we use it. So V equals to minus 0.4 t squared plus 4.4 t plus 1. And we know that t is 5.5 seconds. So now we do the math. Negative 0.4 times 5.5 squared plus 4.4 times 5.5 plus 1. Then V equals to negative 0.4 times 30.25 plus 24.2 plus 1. It equals to negative 12.1 plus 25.2 equals to 13.1. So now we know that the maximum speed that he ran is 13.1. We write it down here as a coordinate, 13.1. Now we are asked to find the distance that Usain Bolt ran at constant speed. So we are asked to find the distance that Usain Bolt ran during this time from 5.5 seconds until the end of the game, the race that lasted 9.85 seconds. From math, we know that when running with constant velocity, the speed is equal to distance over time. Since we are asked to find the distance, we are switching places, and we have velocity times time equal distance. Velocity we know it's 13.1. Now we have to find the time. Since the game lasted 9.85 seconds and he reached the maximum speed at 5.5 seconds, the time is 9.85 minus 5.5, which equals to 4.08 seconds. Now we also have t, so we found t as well. Then we do the math. 13.1 meters per second times 4.08 seconds equals to 53.5 meters. This is the answer. Usain Bolt ran 53.5 meters with a constant speed of 13.1 meters per second.